Hello everyone. Welcome to the new video where we will discuss further with respect to the logistic regression part. If you remember in the last session, we have had a great discussion about, the cost function of logistic regression algorithm. In this video, I told you that we will plan to have a end-to-end project pipeline where we will do each and everything from scratch, and we'll try to implement the regression algorithm. But before that, I think there is a need where we should discuss about the model evaluation metrics also. So just like in linear regression, we have seen that, RMSE or, MSE is a great evaluation metric to check that whether the model is properly doing a regression task or not. Similar to that aspect, we need to carefully verify that whenever we are doing a classification task, does that doing a appropriate manner or not with the help of a confusion matrix. So yes, in today's video we will have a major focus on the confusion matrix, with the help of which you will be able to understand multiple evaluation metrics in one go. For example, accuracy, for example, recall, for example, precision, for example, F1 score. So without wasting any time, let's get started with that concept. So now whenever we are discussing about this confusion matrix, first of all, let's try to understand why it is called as a matrix. So basically, we will try to create here 2 cross 2 matrix today. And I'll try to demonstrate you everything with the help of the previous use case itself. I hope you all remember. In the last session, while discussing about the cost function, I have demonstrated you one use case of diabetes prediction. Do you remember that? So we will try to take that same use case, and with the help of that, we will try to understand the complete idea about this confusion matrix. Let me tell you, this is one of the confusing topic for many of the learners. And if you will try to pay attention till the very end of the today's video, you will be able to get a better understanding of the same. So let's try to understand how this matrix will looks like. So you have observed in the previous session in the cost function that we will be having definitely two values. As it's a supervised learning, so we do have actual values available with us. And then let's say we are applying any of the classification algorithm. So we will be able to get the predicted values as well. Make sense? Now, by the way, whatever things I'm teaching you in this video, it's not specific to logistic regression. It is applicable for all the classification algorithms that we have in machine learning. So please make sure that you will understand this concept in a great detail so that it will be beneficial for all the upcoming classification algorithms. So what I'm saying is this evaluation matrix that we are discussing today is applicable for all the classification kind of a problem. Classification problems. Okay? So it is not specific to logistic regression. You can apply the similar knowledge to other classification algorithms that we will discuss in the upcoming part of the course. Now you know that either our actual value will be 0 or 1, because as of now we are dealing with a binary classification task, right? And it's a binary, when it's a binary classification, we are either having a value as 0 or we are having a value as 1. Or in other words, I can say either the value is positive or the value could be negative, right? Similarly, prediction is also either positive or negative. So I can write the same thing here as well. So either it will be positive or it will be negative. I hope you all are agree with me. Now, this is a kind of a 2 cross 2 matrix, which you will be able to see now on my screen. Now, this is where actual concept will come into picture. And please pay attention how basically I'm writing these terms. See, what I'm saying is कि actual value is positive, means let's say the value of y is equal to 1, right? Meaning that a person is diabetic. I have an actual record where it is displaying at the target value, at the outcome value, that the person is actually diabetic. And my prediction, when I applied the formula of, let's say, cost function of a logistic regression algorithm, or maybe anything, but as of now, because we have just discussed logistic regression in our course, so let me take that example only, that I have applied that logistic regression algorithm, and that model gave me a prediction that, the value of y cap is also 1. It's a good case, right? Do you remember the best case scenario? I think this is one of the best case scenario, right? So what you will write, you will say this term as true positive. Now, how I have written this true positive? Because my prediction is positive, that's why it is positive. And it is true because my actual data is also positive. In short form, you will observe in many of the standard websites and books, you will see as TP. Full form is true positive. Let's move to the next block. I'm moving it diagonally here. Same thing, it's also best case scenario where actually your data says ki a person is not diabetic, means the value of y is 0. And prediction by the model is also saying that the value of y cap is 0. 0. It's again a best case scenario, right? But what is your prediction here? Negative. So you will say it's a case of true negative. It's a case of true negative, which will be represented as Tn here. Tn here. I hope so far so good. Now let's move ahead to the filling of the remaining two blocks that we have. Now this is important. What you are saying is कि actually the patient is not diabetic, the value of y is 0. But my prediction says the value of y cap says he or she is diabetic. Now that is where error will come. That is where the worst case scenario will come. But what is your prediction says? It's positive. It's positive. Your prediction says it's positive. But is that a true positive or a false positive? It's a false positive, right? It's a false positive. So it will be represented by FP. So how I have written, again I am showing you. Please try to understand it very carefully. So what I am saying is, कि my prediction says that the patient is diabetic. But actually the patient is not diabetic. The value of y is 0. That is why we are saying the record is positive because the prediction is positive, but it's a false positive. Now let's focus here. Now you can just pause the video and let me know what this particular block you will call as. Prediction is negative. But if you can see, actually patient is diabetic, but you have applied logistic regression algorithm here. And because of that, you will be able to get an idea that your model is saying that patient is not diabetic. So it means that my prediction is negative, but this is something which we can say is a false negative, which is denoted by Fn. So these are the 4 blocks in a confusion matrix, and with the help of which you will be able to get the complete intuition behind the different evaluation metrics that we have. For example, first of all, I would again suggest you just pause the video and check, is this point is clear? What is true positive? What is true negative? What is false positive? What is false negative? Always when you're filling this table, check what is the prediction is all about. And then once, whether it is positive or negative, after writing that, check is that true or false. If it is true, then it will become true positive. If it is false, then it will become false positive, and so on. Now, with the help of this confusion matrix, we will be able to evaluate different model evaluation things. For example, if let's say someone will say, what is the meaning of accuracy? So accuracy is nothing but is equals to how much total positivity is there. So it is nothing but what is the true positive value plus negative value. It is something which is correct, right? Divide by total 4 terms. True positive, false negative, plus true negative. So this is the first thing which we can evaluate very easily, which is accuracy. Second evaluation matrix will be recall. What is recall? Recall says that out of actual true positive, how much or how many, in case of this actual positives, how many of them are true positives? So if you can see, the first column of positive indicates an actual positive. So what recall says that out of total, I would say, actual positives, out of total actual positives means true positive plus false negative, because this first column indicates total actual positives. How many of are true positive? So this is the literal meaning. So it will be TP divided by TP plus Fn. Another thing is something which we call as specificity, which will take care of true negatives. So it will say specificity. It will say out of total true negative. So out of total actual negatives, how many of them are true negative? So it will focus on the next column that we have. So how many of are actual true negatives? So it will be Tn divided by, you will see Tn plus Fp. Tn plus Fp. So here it is sum of actual positives that we have And here it is sum of actual negatives we have, actual positives, and here it is actual negatives. So I think so far things will be pretty much clear to everyone. Next important term that we have is precision. Apart from these three terms, precision, another evaluation metrics in a classification part, which basically takes care कि out of total predicted positives, when I'm saying out of total predicted positives, it means that somehow I'm referring the row part now. I'm referring the row part now because predicted value is a row part, right? How many of them are actually true positives? So what I'm saying is that precision is TP divided by TP plus, I would say, FP. So this is the sum of, I would say, predicted positives, right? Sum of predicted positives. So out of the given predicted positives, how many of are actually true positives? This is given by the indication of precision. So all these are the different evaluation metrics that we have depending upon different circumstances, different use case. We prefer to go for different types of evaluation metrics that we have. For example, let me again give you one simple example. This is again one of the most important interview question. People can ask you that out of precision and recall, let's say we are talking about a use case of diabetes prediction, right? Diabetic prediction. Or maybe I would say any healthcare use case. Any healthcare use case, right? In this case, if you will be able to observe, we have seen that we have, let's say we are comparing two evaluation metrics. One is recall, one is precision, right? So the precision says it will be TP divided by TP plus FP. Recall says it will be TP divided by TP plus FN. I hope you all remember, right? Now, if let's say I will say ki with respect to this healthcare analysis, with respect to this diabetic prediction, which one is I would take care in a better manner. So if you can see in the recall will be higher when the below term will be lower. It means somehow I need to reduce this value of Fn, right? What is the meaning of false negative? False negative meaning will be, let me just remove all these things so that the confusion will be very less. False negative will be where actually patient is diabetic, but my model is saying that he or she is not diabetic. That's a very worst case scenario with respect to healthcare domain. So always remember, in case of any healthcare problem, our target is always to reduce this particular error, this particular false negative term. Or in other words, I can say, I will always take recall as a, important evaluation metrics, as a important, I would say, evaluation metric specifically for the healthcare person. Why I'm saying so? Because this situation is very dangerous as comparable to the another type of error. Although both the errors are very bad, but if I have to compare this Fn and Fp, I would say Fn is more dangerous because in this case, patient is genuinely is having some problem, some issue is there, some healthcare issue is there, but my model is saying he or she is fit. That's a dangerous problem as comparable to this one, where my patient is fit. Let's say patient is not having a diabetic issue, but my model is saying that he or she does have, right? Maybe he will take care more about their health and everything. It's a better as comparable to the another situation, right? Although again I am saying our major target is to reduce both of them, FP as well as Fn. But specifically for healthcare, if someone will ask you that which particular evaluation matrix you will choose as a priority, your answer will always be, it will be recall. Because precision will take care of FP. You have to reduce the FP in order to increase the value of the precision. But specifically for healthcare, the good evaluation metric will be recall as comparable to precision. But let's say now I will give you one situation, one problem, and you can just let me know after understanding the concept pretty well, that let's say we will be having an issue of spam classification. So I hope you all know that in our mails also, there is an algorithm which is internally going on, which specifically identifies that whether a mail is important or it's a spam mail. Accordingly, it will try to classify that point. Now, if I'll ask you this question, that can you tell me In that case, what do you think? Recall is more on priority as an evaluation matrix, or precision is more on priority as an evaluation matrix? I'm looking forward to your answer, but let me give you the answer. It would be precision. Now, the question is, how is that so? You only think over it and let me know. But the correct answer will be, so if anyone is saying that precision is the one, then he or she is correct. Logically, you have to give me the answer, that then only I can say ki if logic is correct or not, but precision is the one. Why is that so? Think over it. In the upcoming videos, I'll let you know why precision is the one. But in this video, I'm giving you as an assignment. Now, let's move ahead. If, let's say, in few situations, you will say ki Priya, if recall and precision both are equally important, at that point of time, we usually have some other metric which is called as F1 score. F1 score, which is the combination of precision and recall, where you will say 2 into precision into recall divided by precision plus recall. So you can see it's a combination of both of them. So if at any point of time you won't be able to decide, or there is any situation, there is any use case where you feel that both of them are equally important, you can always go for this another evaluation matrix, which is a F1 score. Now, as I told you, accuracy, again, it's a reliable thing which we usually evaluate. There are few instances, for example, when our data is imbalanced. What is the meaning of that? The simple meaning is where, let's say, you will be having for zero class, maybe let's say I'm giving you one simple example, the people who are not diabetic, let's say we have 1,000 records. But the people who are diabetic, let's say we just have 200 records. This is the meaning of data imbalancing. In that case, definitely accuracy is not a good metric, but in other factors, the accuracy is a better way. Recall, I have already talked about. Specificity, to check it out that how many actual negatives are there, right? So all these are the evaluation metrics that we have, which we easily able to compute with the help of this confusion matrix concept, right? When we are doing the implementation, it's very, very easy. From sklearn, we directly import this confusion matrix and we will be able to evaluate all these terms. In the upcoming sessions, when we are doing a project end-to-end, I will show you the complete end-to-end idea that how the implementation will happen. But before that, I request you all to again rewatch this video, make your notes, document it pretty well, and try to understand whatever concepts I have talked about today, whether it with respect to true positives, false positive, false negative, true negative, how basically I'm writing this term, that is important to understand. I don't want anyone to cram these stuffs. You have to just understand these concepts in a very logical manner. And after that, how basically accuracy, recall, precision, specificity, and F1 score is evaluated. So now I think that you got a better idea about the confusion matrix, how basically with the help of which we will be able to evaluate multiple evaluation metrics like precision, recall, F1 score, and so on. So I think now it's the right time that in the upcoming video, we will discuss one hands-on project where we will see whatever knowledge we have gained so far with respect to logistic regression. We'll try to implement that. So I'll see you all very soon in the upcoming video.